My name is B. Chansi Nikita, PCE B section in our college. I am discuss about transistor biasing. First, we have discussed transistor biasing. What is transistor biasing? Transistor biasing is defined as the proper flow of zero signal collector current, means IC, and the maintenance of proper collector emitter voltage during the passage of signal. Transistor can operate three regions, namely active region, cutoff region, and saturation region. To operate the transistor is in the desired region, we have to apply the external DC voltage of correct polarity and magnitude to transistor biasing. In this transistor biasing, three regions are operate: cutoff, active, and saturation. Next, need for transistor biasing. What is the use of transistor biasing means? For proper working, it is essential to apply voltage of correct polarity across its two junctions. If it is not biased correctly, it would work inefficiently and produce distortion in the signal. Operating point should be affected due to the temperature variations and device variations. Further, for various applications, transistor biasing is used. Next, these region of operations are produced in this BJT, cutoff region, active region, and saturation region. These three regions are plotted in the graph: base emitter junction, collector base junction. And why we can use these three regions? First, cutoff region base emitter junction is reverse bias and collector base junction is reverse bias. What is the application of this cutoff region means? It acts as a switch. Next, active region. Base emitter junction is forward bias and collector base junction is reverse bias. This region is useful for an amplifier. Next, saturation region. Forward bias, base emitter junction is forward bias and collector base junction is reverse bias. This region is useful for it acts as a switch. This cutoff region and saturation both acts as a switch. Need for stabilization. The need for stabilization lies in various dependence of IC values beta 1 plus beta. These are included in this need for biasing. We will see temperature dependence of IC. We know the collector current is given as IC equal to beta IB plus 1 plus beta into ICB. This IC is dependent on temperature dependence of IC. Beta IB plus 1 plus beta into ICB. Base current IB is constant beta value with respect to plus 1 plus beta into ICBO. ICBO means base collector to base leakage current, where beta is a common emitter current again. Next, IB equal to base current, ICB not equal to leakage current, IC equal to collector current. These three variables are strongly temperature dependent. Hence, with increase in temperature of any of these parameters, changes IC beta values. So operating point is shifted to the other region. Operating point means the small signal of VCE, IC of a transistor is known as operating point. Next, Variation in parameters between transistor of parameters. Even after the advances in semiconductor technology, the transistor parameters such as beta vary widely between transistors even of same type. Change in beta will shift the operating point in any undesired region. Beta means collector base current. Collector emitter current vary widely used between transistors even of same type. This beta is changes in every point in this operating region. This is the variation in parameters between transistors of same type. Next, thermal runaway. The collector current is given as collector current IC equal to beta IB plus 1 plus beta into ICB, where IB equal to emitter current, IB equal to base current, beta equal to emitter, IC equal to collector current, ICB not equal to collector to base leakage current. Here 1 plus beta is a temperature dependence of IC. If temperature changes, then ICB not changes with turn changes IC and operating point. Flow of collector current in the collector circuit produces heat at the collector junction. This will produces in the thermal runaway because it is have high capacity. In this thermal runaway, it produces heat and at the collector junction. This raises the temperature, hence ICB not increases, which in turn increases collector junction, and the whole process repeats again. Such successive increases in IC will drive the operating point in saturation region. This thermal runaway produces in this region means saturation region. This process is called thermal runaway. This is a very dangerous situation because excessive heat the transistor can burn out. Means in this thermal runaway heat is produced more. That's why it is dangerous for transistor because it is burned out the transistor. Next, types of transistor biasing. In types of biasing, we will see four types of transistor biasing. First one, fixed bias circuit, collector to base bias circuit. Fixed bias circuit is also called as single base resistor biasing or base bias, collector to base bias. Next, third one, voltage divider bias circuit or self bias, emitter bias or modified fixed bias circuit. Fixed bias means it is having poor stability is produced in this fixed bias. Next, in this fixed bias, we can overcome collector to base bias. In this collector to base bias is also more, more than fixed bias. Next, this will collector to base bias will implementing voltage divider bias. In voltage divider bias, stability is more, means stability equal to 1. Emitter base bias is similar to the voltage divider bias. This is all about transistor biasing. First, we will see what is transistor biasing, need for transistor biasing. Next, need for stabilization. These are the three types of transistor biasing. This is all about my topic in this transistor biasing. Thank you.